In this video, we will go over two examples for calling a method of math. Here are the subgoals for calling a method. For the first subgoal, we classify the method as a static method or instance method. If it's static, we use the class name. If it's an instance, we must have or create an instance. For the second subgoal, we write the method call using the instance or class name, .method name, and open and close parentheses. For the third subgoal, we need to determine whether the parameters are appropriate. This has two parts: the number of parameters that need to be passed, and the data types of those parameters. For the fourth subgoal, we determine what the method will return, if anything, and where it will be stored. And finally, for the fifth subgoal, we need to evaluate the right-hand side expression. The value is going to be dependent on the method's purpose. What does the method do? For the first example, we are going to use a method to access the value of pi. We begin with subgoal 1 and classify the method as a static method or instance method. Pi is stored as a value in the math class, and the math class only has static members, so this method is static. When we write the method call, we use the class name, which is math, followed by dot, followed by the method name and open and close parentheses. However, in this case, we're not actually calling a method, we are calling data. Here are some of the constants in the math class that you can access: pi, and the base value for natural logs, e. For pi, we have the constant name math.pi. Note that pi is in all capital letters, indicating that it is a constant. So, to access the value of pi, we just have math.pi. There are no necessary parameters because we are calling data, not a method. For subgoal 4, we determine what the method will return and where it will be stored. The value is returned and is a double. We need a variable to store the value. Let's declare a double. We will call it pi and assign it to the value math.pi. For our second example, we want to get to the square root of pi. As previously mentioned, the math class only has static members, so for subgoal 1, we classify the method as static. For subgoal 2, we write the method call. We use the class name, math, followed by a dot, followed by the method name, followed by open and close parentheses. The square root method is called sqrt, so we have math.sqrt with the open and close parentheses. Here is the API for the method sqrt. As we can see, sqrt takes one parameter, which is a double, and it returns a double. So for subgoal 3, do we have parameters? Yes, one parameter, a double. And because we want to know the square root of pi, our parameter in this example will be math.pi. For subgoal 4, we want to determine what the method will return. In the API, we saw that sqrt returns a double. We will need a variable to store that value. Let's declare value, which is of type double, and it will be assigned the value math.sqrt of math.pi. For subgoal 5, we evaluate the right-hand side expression and see what the value is going to be. Looking at the right-hand side, we see that it is calling the square root method from the math class, and it is calculating the square root of what is in the parameter, which is math.pi, which is a double. We get the square root of pi and assign it to the variable value. Here are some additional math class methods.